We're going to make this a short test, won't be very long. Talk a little bit more about sensors and stuff. Automotive Electronics Test 10. And we talked a little bit about piezo resistive sensors. Piezo electric, piezo resistive. Technician A says the piezo resistive sensor changes resistance as a function of temperature. Technician B says the piezo resistive sensor outputs its own current based on the pressure it is exposed to. What do you think about that? Anybody know what a piezo resistive sensor is, what I was talking about? Basically, any piezo sensor is going to be reacting to pressure, but a piezo resistive sensor is not going to put out its own current. It's basically going to change resistance with pressure, is typically what a piezo resistive sensor does. And that's the way some of the knock sensors are. You know, because an engine knock sends waves of pressure through through the metal in an engine, and they put the knock sensor in the place where it's most likely to feel it. Some of the General Motors knock sensors are actually screwed into the water jacket because of the pressure in that water that's going to react to pings and stuff in the combustion chamber. Okay, so your ping is, what is your ping? What's a ping? Anybody know what a ping is?
How long it takes to get from one point to another?
Well, that's depending on what you're talking about, I guess. But basically, whenever you're hearing ping and you're hearing detonation and you're hearing spark knock, you're basically talking about an explosion that happens while the piston's on its way up. And the flame front of that explosion comes together and bangs the top of the piston and makes a ringing noise. It's sort of, if you ever hear it on a vehicle, it's going to sound, it's like little random rattling noises like marbles or ball bearings or something. It's going to come from the engine, you know. And they don't have a steady cadence to them. It'll be like a noise sort of like that. And you'll usually hear them pulling a hill, or whenever, you know, if the engine starts to get really hot, you're going to get some detonation because of the temperature of the engine. Because when you squeeze the air-fuel mixture, you're almost about to fire it anyway. It's almost about to light off like a diesel is, but it won't quite do that. It's under the threshold, but just under the threshold. Then when the spark triggers the firing, it actually causes the flame to start burning while the piston is on the way up, but it gets its full push when the piston's already on its way down. Now, the piezoelectric sensor operates by doing what? This is what I was talking about, the little quartz. You got a thin ceramic disc voltage generator attached to a diaphragm that stresses the crystals in the disc. That's what those crystals are about. And that's, you know, a couple of different ways that they do pressure. Pressure transducers, like, have you ever seen, like, let me ask you this, you remember the oil pressure sending unit that you put on the Dodge Charger? You remember that one?
Yeah.
That really annoying thing to get to. That wasn't piezo, but it was a transducer, and basically it changes its resistance in response to the pressure that's delivered to it from the oil gallery. But piezo sensors are, and it didn't create current either like a piezoelectric sensor will do. But anyway, basically there are sensors that just operate with pressure, and they'll have various different things. Technician A says a potentiometer is a voltage divider circuit used to measure the movement of a component. Technician B says a magnetoresistive sensor alters current flow through the sense circuit when influenced by the magnetic field. Both of those guys are correct about that. You need to learn about these sensors because you need to find out what it is that is going on in a little sensor's mind, or a sensor's little mind, so you can tell whenever you're checking it what kind of signal is it supposed to put out, how do I measure that signal. If at all possible, look at some good vehicles to make sure that you understand that. And so you got a low voltage on the pressure supply circuit, could be caused by any of the following. When it says pressure supply circuit, that's really interesting. I think they messed the words up on that one. A low voltage on the pressure supply circuit could be caused by any of the following. It's basically talking about a sensor supply circuit. You remember what the supply circuit's all about? Watch this. This is a list, define, explain thing. There are 3 wire sensors and there are 2-wire sensors. All right, if I've got a 3-wire sensor, what 3 things am I going to see at a 3-wire sensor? Do you remember? What am I going to see on those 3 wires at a 3-wire sensor as opposed to what I'm going to see on a 2-wire sensor?
3 wires. 3 wires.
Yeah, well, I'm talking about what are you going to see delivered to and from. On this one here, you're basically, and both of these go to the PCM, right? All right, on this one here, both of them go to the PCM. On this one here, all 3 of them go to the PCM. But you're supposed to be able to tell me what's there.
Is it 2 powers and 1 ground?
Not typically. What you're going to have here, and we've done this before, signal return. That's a ground. That's your reference. And this is your signal. This one varies based on the changes that the sensor is supposed to measure. On this one here, that's typically going to be like a temperature sensor or maybe a grounding switch. And so what you got right here on the temperature sensors was you're going to have 4.6 volts, just under 5, and here you're still going to have signal return. All right, now signal return will typically be shared from sensor to sensor. All of the 3 voltage sensors are going to share the 5 volt signal, but these, since the signal and the reference voltage are delivered on the same wire, they're not going to share anything except signal return with other 2-wire sensors. If you got another 2-wire sensor over here, that one is also going to have its own discrete input, but this right here will be tied to that. So all your signal returns will be tied together. Your reference voltages on 3-wire sensors will all be tied together. Now, how many of you guys are going to be able to remember that the next time I ask the question? You know what I mean? Get to where you can draw that. Explain it to somebody else. Do whatever you have to burn that in. You know what I mean? I mean, get out of the mindset of if I can just get through this class period, I can go have some fun with wrenches. You know what I mean? You need to burn this in so you'll be able to do it. All right. I mean, I like to be smart enough to where if they ask me a question, like if I'm going to get a job somewhere, that I don't, you know, when I was over at Lincoln Mercury, going to work over there back in 1984, you know, he was asking about EGR and all kinds of stuff. So what am I supposed to tell him if I don't know the answers to those questions? I'm not going to work there, and I'm going to have to go look for a job somewhere else, maybe changing oil or, you know, doing something really simple, you know, hopefully, if they'll hire me for that. You know what I mean? You want to be the guy that knows the answer, or the gal, whatever. Okay, look at here. Now then, number 4. Let's go back. A low voltage on the supply circuit. Like this is a supply circuit. I got a low voltage here, or if I got a low voltage there, which is also the signal circuit. What can that be caused by? An open in the supply circuit wire, a short to ground in the supply circuit wire, high internal resistance in the sensor, excessive voltage drop in the supply circuit.
I would say either B or D.
I would say, and that particular question is so stupid because of the answer they claim is right and the way they've got it worded. I don't know who wrote that or if they were just thinking about something else when they wrote it. It can be an open in the supply wire. It can be a short to ground in the supply circuit wire. But if you want to get that one right according to their answer key, and I don't like that, put B. But an open or a short, an open in the signal circuit, you know.
What was 1?
Wait a minute, let me think about what I'm looking at. Excuse me, I was looking at that. A low voltage on the sensor supply circuit could be called, I'm looking at 2 questions, they're almost exactly the same. Boy, that messed me up. I may have given somebody a bad rap there. A low voltage on the pressure supply circuit could be called many of the following except. Okay, so could it be an open in the supply circuit, the supply circuit wire? That probably wouldn't be so, because if it was an open, there'd be no voltage instead of low voltage, right? Of course, you could say low voltage would be no voltage. Most of the time it's defined that way. A short to ground in the supply circuit wire would do it. That would be no voltage. Well, I'm still not liking that. Excessive voltage drop in a supply circuit, well, that may cause it. That's about the screwed upest question I think I've ever seen. Put B so you'll get it right, but we need to, anytime you've got low voltage, it can be an open, it can be a short to ground. It could be probably not high internal resistance in the resistor. Oh yeah, well, wait a minute. Look at that. All of the following except, I didn't read the question right. I deserve to be smacked for that. Next time I've got to slap myself, I'll do it twice. Okay, so B is going to be the right answer to that. Number 5, I stopped reading before I got to accept. That'll mess you up on an ASE test, let me tell you. I got confused myself there. High voltage on the pressure sensor signal wire would most likely be caused by which of the following, and number 5 would be an open in the signal circuit. I don't really like that answer, but let me show you this. What do you suppose would happen? Let's say that I'm looking at a TP sensor wire, and this right here, obviously this is 5 volts. Let's say that at rest, this is about 1 volt. And this is obviously going to be 0 volts, right? All right, now, what do you suppose is going to happen to these voltages if I cut this wire right here? Well, this is the ground. So you got 5 volts here. If you cut that wire right there and there's no ground, then what you're going to see on all of these is 5 volts. That means that you're going to be off the chain on your voltage all the way across the way. Over here, you're going to see nothing but straight voltage too, which you're going to have you're going to be able to read the same amount right here as you are right here. Now you won't read the full 5 volts here because there's a current dropping resistor inside there. Okay, we're in the PCM.
What was 1?
That's D. Neither one of those guys is right. All right, the Technician A says the knock sensor output voltage should increase as it detects an engine knock. Technician B says the knock sensor voltage should be a square wave pattern. That's A only. And I will tell you this, there is a lot of the times these vehicles, the knock sensor will go lousy on them, and they'll throw you a knock sensor code. Tim's got that little pickup truck that he got for a hunting truck, and it's got a knock sensor code. And it's been there a long time because nobody wants to pull the intake manifold off to get to the knock sensor, because they can drive it with a bad knock sensor and it ain't that big of a deal. But those knock sensors are on just about everything, you know. Technician A says a Hall effect sensor shows a trapezoidal shaped waveform on the lab scope, indicates a tone wheel air gap may be too wide. Technician B says the Hall effect waveform should have round edges. What do you think?
I'll say B.
This is what it typically looks like. Hall effect switch is going to put out a signal that looks like that. Are those round edges? Shouldn't have one there. What's a trapezoid?
Like half an octagon, you know. The 6th one.
Huh?
I'm trying to think half of the. I can't think of it. Screw it.
Octagon is 8.
No, thank you, Captain. I know that. That's why I said not an octagon.
That's a trapezoid right there.
Yes.
Right?
If you add 3 more, it makes the 6th one, and I can't think of it.
Yeah.
Triangle.
That's a trapezoid, basically. I always think about it because it looks like you're looking at a trap door from one end or something like that. Quincy, are you having, you getting tickled about something over there? Actually, number 7 is neither one of those guys are right. Trapezoidal waveform, I don't really like when a scope shows a trapezoidal waveform. It makes me think my scope's going crazy. Potentiometer is suspected of being faulty. Now, what do we use a potentiometer for? What's this? Anybody looking at me right there? 3-wire sensor. This little thing in here moves. What do you think? What are we using this for? What does this look like? I think you may have been the one to change it.
It's right there.
Spark plug,
Huh?
those are top spark plug.
No, this is not that.
Spark plug. It's a,
You know Quincy.
yes, it's right there at the top though. It's, my mom has one on her Mountaineer. Oh my God.
It's a throttle position sensor, okay? It's basically gonna be on the opposite end of the throttle shaft from whatever operates the throttle. That's a throttle position sensor, it's a potentiometer. Okay, now let's look at this. You know how a potentiometer is wired on the inside, right? This is resistive, either paint or something else that's resistive. And this one here slides up and down. 5 volts, sig return, and sig. Got it? As this slides closer to that, this is going to go up closer to 5 volts. Won't usually go over about 4.5, even if you're wide open throttle. But the closer it goes to signal return, the more that's got to flow to get to it, and it's going to go, the voltage is going to go down. So this is usually from about 1 to 4.5 volts that you're going to see, and it's going to vary in between there. Okay, a potentiometer is suspected of being faulty. Voltmeter testing indicates there's 5 volts in the signal circuit when back probed at the sensor, regardless of wiper position. This is the wiper right here, see? Technician A says this can be caused by an open sensor return circuit. Technician B says this can be caused by short to ground in the supply circuit. Okay, in the signal circuit. Okay, so what they're saying is they're reading 5 volts right here. What were we just talking about? Technician B said this can be caused by short to ground in the supply circuit. If this right here was shorted to ground, would you have 5 volts here? No, because that would never even deliver 5 volts to the sensor. So it's not going to be a short to ground. Technician A said it could be caused by an open sensor return circuit. What did I tell you? If I cut that wire, everything's going to go to 5 volts. You'll actually even read 5 volts at the sensor on the signal return circuit. Okay, so somebody can tell me what the right answer is after having gone through that. Based on what I just told you and what I just drew,
A.
it's going to be A. That's right. When inspecting magnetic reluctance type sensors, all of the following must be checked except A, bias voltage, B, proper contact between the sensor and the tone wheel, C, proper mounting of the sensor, or D, tone wheel teeth condition.
What's tone wheel teeth condition?
No, bias voltage. Actually, you're not going to have contact between the sensor and the tone wheel. I don't like the way this test is written at all, but here's something. Watch this. You can take that, a Ford, or like I can take my little board over here that's got my fuel injection and ignition system on it that makes sparks and pops injectors and all that stuff. And you can hook up pins 21 and 22 backwards to the engine controller. And you can spin that thing up. And even if you're looking at it with your scan tool, it'll start reading in RPM on some scan tools, and then the RPM will drop to 0 because it'll recognize that that pattern's upside down. And you won't ever get any spark. You could probably trick the heck out of a shop by taking the 2 pins out of the engine controller, swapping them around, putting it back together, and they'd work on that thing for weeks. Unless they had one really sharp cookie that checked pin for pin to determine which one was supposed to be what. And sometimes that's difficult to do if you don't know how to look it up. That's what a magnetic reluctance sensor is, the one on that reads off that tone wheel on the front of that engine, or that one over there on that board that's got that wheel spinning next to it is one of them. So keep that in mind. The power seats do not move fore or aft. They don't move forward or backwards. The technician notices that the motor attempts to move the seat then stops. What's the most likely cause of that?
C.
Hmm?
A faulty PCT. Well, PTC.
Is that what you read in the book?
No.
The technician notices that the least likely cause of this.
Obstruction under the seat.
No, you can have an obstruction under the seat. You could have a short in the motor armature. You could have a binding track, but you're not going to have a faulty PTC. One time, there was Scott Weaver, this guy that I know that writes. He's got a shop. He's been doing car work about as long as I have. And he said that there was this car that came in and it had this noise that it was making whenever you'd sit in the seat. It would go bzzz. You lean back, you put weight on the seat, it go bzzz, like that. And so he says, I wonder what in the world that noise is. It's a crazy noise, crackling noise. Bzzz. And so he had his helper sit on the seat, and his helper would sit back and it would buzz, and they started cutting up with one another, going bzzz, 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 like that. And then he decided he'd poke his head under the seat and look and see what was going on. And there was a taser under there. And it was pointing right at the guy's rear end. And he says, you sit still, sit still. He said, you got a taser pointed at one of your, rear end cheeks. And he says, get off. I get tickled thinking about that. He had to work that taser out of there. But he says, when you looked, he'd see that bright blue spark. It's amazing to me they didn't run it out of battery juice, because it takes a lot of power to dry fire that thing. But anyway. But it was black. The taser was black and it was dark under there, and you couldn't see anything under that seat. But when you saw that lightning up there, it's, but anyway, the guy got really pale when he told him he had a taser pointing at him. All right. There's another little story here. This lady comes in and she says, I've got this horrible smell in my car. And it's been here for a while and it's been getting worse. And so the mechanic goes and starts looking around in the car, and he looked under the seat, and there was some lasagna that she had been hauling in there, and apparently she took off really fast and it slid under the seat and she forgot about it. And that lasagna was rotten. There's another one where this guy says, when I turn off my truck, my radio keeps playing. And so the guy, one of my guys that's a radio nut, he went out there and said, I gotta go check this out. So he goes out there and he switched off, and he still heard it. And he found out the guy had a great big boom box behind the seat that was set on the same station, and he leaned back in the seat and turned the boom box on. And he was hearing the boom box. He wasn't hearing it. So anyway, true story. The scan tool displays 5 volts for the ambient temperature sensor. This indicates what? A, an open in the sensor signal return circuit. B, an open in the sensor return circuit. B, an open in the signal return. C, an open in the sensor. That's a crazy bunch of answers. Sensor return and signal return. What am I supposed to think about that? Why do they use them words? An open in the sensor is basically what you're going to have there. Like if you unplugged it, you'd still read that. When technician A says the map sensor reading with the key on engine off should equal barometric pressure. Technician B says when the engine is started, the map sensor signal voltage should increase. A only, because it's going to typically decrease whenever you start it. Why do we need to know barometric pressure? If the air is not as dense because you're at a higher altitude, your air-fuel mix is going to be different, right? A vehicle with a 4-wheel ABS has a problem with the right rear wheel locking during heavy braking. Technician A says this could be caused by a bad speed sensor mounted at each wheel. Technician B says the speed sensor mounted at the differential could cause this problem. That is a crazy question too. This test here is really was written by some crazy person. 4-wheel ABS, right rear wheel locking during heavy braking.
C.
Well, the speed sensor mounted in the differential is not going to cause it because it's got. Well, I will tell you. Like in the GMC, the sensor is the output shaft sensor on the, there's a sensor on the output shaft that measures the drive shaft spinning, and it counts on that one sensor to determine what the back wheels are doing, and it has 4-wheel ABS. So this is a sort of a crazy question. ABS has a problem with right rear wheel. That sounds to me like some other kind of a problem. What they're saying is supposed to be a bad speed sensor mounted at each wheel. And that's a dumb way to put that. I'm just really disappointed in this test. This is just not a test that I am enjoying right here. Number 13 is basically going to be A. Make sure she grades these tests, so make sure you put A down there. Sometimes, whenever we're doing these, even though she grades the test, and people still make lousy grades for some
What
reason.
was number 2?
It was 2.
What you some of you guys tell him about number 2?
C and B. C.
Anybody got any questions or comments? You find any oil leak on your Suburban?
No,
Even it's not leaking at all?
no, I let it run longer, see. but
Is it not wet? It's not wet under there?
I used some brake cleaner, but just waiting.